Welcome to ETE MCQs. Now let us solve a NPTEL assignment problem. That is from digital circuits. Which of the following is not a prime implicant for the given function f of a comma b comma c comma d is equal to summation 1, 4, 5, 10, 12, 13, 14 and 15. So we are supposed to find which of the following is not a prime implicant. Which is not a prime implicant. So before we go ahead to solve the problem, let us see what is an implicant. In Kmap, you will have implicant, prime implicant and essential prime implicant. What is an implicant? A single one or a grouping of ones? Or more than one ones grouped to form a product term. To form a product term. Okay, that is an implicant. You can have a single one and you find the respective product term, you call it as an implicant. You can perform a grouping among the ones and finally you will get a product term. That term can also be called as an implicant. Now what is a prime implicant? The grouping of ones should be maximum in Kmap. In Kmap, if you just after grouping, if you are able to, after performing maximum grouping, if you are able to, if you get a product term, that product term is called a prime implicant. All the three happens in a Kmap. An implicant is a single one, or you just perform a minimal grouping and then you get a product term. That product term is called an implicant. You just perform maximum grouping of ones and you get a product term. That product term is called as prime implicant. Now what is the essential prime implicant? In Kmap, a particular one is grouped, okay, it undergoes a maximum grouping and only that particular grouping can yield a product term. That product term is called a essential prime implicant. In other words, the only maximum grouping performed for a one, the only maximum grouping performed for a one which cannot be grouped to form any other product term. Any other product term. Okay, in other words, all the terms you have in the minimized Boolean expression, all the product terms you have in the minimized Boolean expression is an essential prime implicant. Okay, all the product terms you have in the minimized Boolean expression is an essential prime implicant. Okay, now I will give you final examples based on the same problem. We will be able to understand it easily. Okay, so let us solve this problem. So we have got a 4 variable Kmap, A, B, C, D or its variables. So we have 16 cells in this Kmap. Now let us put ones that correspond to these values. So for 1 it is 1. For 4 it is 1. For 5 it is again 1. For 10 in Kmap cell we need to put a 1. For 12 it is, and for 13 it is 1, 14 and 15. So these are the cells that are that corresponds to 1. Now we need to perform the grouping. Now let me relate it to implicant, prime implicant and then essential prime implicant. I am just going to perform grouping just to understand implicant, prime implicant and essential prime implicant. Finally, we can get the solution. We can identify which particular product term is not a prime implicant. Okay, now you just consider this one. This one's only possible grouping can be done with, can form a pair with the neighboring one. Only this adjacent cell is one. So this grouping is fine. If you just consider only this one and you perform a grouping for the single one, this can be called as an implicant. This is an implicant. I just write the corresponding term over here. I am just giving an example. The example is for this term you will have the product term as A B dash, because A is 1, B is 0, and here C is 1 and D is 0. So you have A B dash C D dash. That is the A B dash C D dash. This is an example for implicant. Likewise, when I consider this one, it can be grouped along with this. This is an implicant. It's an implicant, a single one or a group of one. But the grouping is not maximum. If it is maximum, I should at least include these 4 ones. I am not doing that. So this is an example for implicant. So what you get is B is constant in both the cases. So it is B C dash D dash. B C dash D dash. So this is an example for implicant. Okay, now let us just see what a prime implicant is. Okay, prime implicant, the grouping should be maximum. I can just perform this grouping. This grouping is far better. So what you get is B is constant in all the 4 cells, and here C is equal to 0 is constant. So it is BC dash. BC dash is an example for prime implicant. It's a wonderful example for prime implicant. So if I perform this grouping, so this is a wonderful example for prime implicant. So for prime implicant, what you get is AB. AB is a product term. That is a wonderful example for essential prime implicant. Because if you consider this one, you just notice, in order to group this one, this is the perfect maximum number of ones you can group. So this is the essential prime implicant. This is a implicant as well as it's a essential prime implicant. So this again for this B C dash is also a essential prime implicant. It is both prime implicant as well as essential prime implicant. But B C dash and AB is basically, you cannot call it as implicant, because implicant is just a grouping with minimal ones. Whereas in these two cases, the grouping is maximum. Hence, it should be prime implicant, and if that grouping includes a one which is not included by any other one, then that particular product term becomes essential prime implicant. That is what is happening here. For the sake of this one, AB has become a essential prime implicant. For the sake of this one, I can perform this grouping. There is no better grouping than this. So this is both a prime implicant as well as essential prime implicant. So what you get is A is 0 constant, C dash D. So it is A dash, C dash D. A dash, C dash D. It is both a prime implicant as well as essential prime implicant. Okay, likewise, there is no better grouping other than this. It accidentally includes this one also. So you don't have to perform any grouping for this one in particular. Whereas if you consider this one, you just notice, if you consider this one, for the sake of this one, the perfect grouping is the prime implicant grouping BC dash, because it forms a quad, and at the same time there is no better grouping for this one other than this quad. So it is both a prime implicant as well as essential prime implicant. So BC dash is also a essential prime implicant. Right now I haven't solved the problem. I have just explained you what an implicant is, what a prime implicant is, and what is the essential prime implicant. Now let us solve the problem. Right now the Kmap is filled. Now first we need to locate the one which has got only one possible grouping. Then you directly move to essential prime implicant. You don't look for implicant or prime implicant. You can directly attack the or obtain the essential prime implicant if you just focus on one which is looking for help, which has got only one possible way to group it. In that case, if you notice this one, it cannot form a quad because all the other sides it doesn't have a one on the other adjacent cells. This is the only cell which has got one adjacent to this one. So this has to be a essential prime implicant. Just because we are grouping we just form a pair, you cannot call it as an implicant or prime implicant. There is no better grouping than this. So this is a definite essential prime implicant. So what we have is F is equal to, I am just writing the product term that corresponds to this essential prime implicant. It is A C D dash. So you have F is equal to A C D dash. This is a essential prime implicant. Likewise, you look for the next one which doesn't have no better grouping option. You just consider this one. You cannot think about this. If you think about this, this is one possibility. For the sake of this one, you can form a quad. Okay, whereas this one, the grouping should be maximum. Only then you will get a essential prime implicant. So for the sake of this one, you better form a quad. So combine everything and form a quad. The entire row is being taken. So what you have AB plus AB. Okay, so this is the next product term. Next you look for the one which doesn't have no better option or alternative. You can either choose this or this. It is fine to choose this because this will yield a product term with 3 literals. Again I repeat, each and every term over here, whatever I have underlined is a literal. The variable in its actual or complemented form, each and everything is called as literal. Literal. Now, so this is an essential prime implicant due to this one. This is the one which has made this as an essential prime, and this one is the one which has made this term as this product term as an essential prime implicant. Next, for the sake of this one, you just notice it is the only better option you have is to form this quad, which obviously includes this one. And for the sake of this one, you cannot form a quad for this one, so form a pair. And look for the one which is not grouped. So this has been grouped already. It is, you don't have to go for a grouping for the sake of this one. So for the sake of this term, this one, we get the essential prime implicant as A dash C dash D. A dash C dash D. A dash is a literal, C dash is a literal, and D is also a literal. Plus finally, for the sake of this one, it is what I can say. It is irrelevant if you just look for just a pair. You can form a quad. You don't have to bother about these 3 ones are already grouped. You don't have to think about it. We need to end up with a Boolean expression in which the product terms should have less number of literals. Number of literals should be minimum. The number of literals should be less. Number should be minimum or less. And for the sake of this one, it is fine to consider form a quad. So what you get is B C dash. B C dash. B is constant along the rows, and C dash, C is equal to 0 is constant in all the 4 cells. So it is B C dash. Now whatever product term you have here is an essential prime implicant. Now what is the question? Which of the following is not an essential prime implicant? So you notice AB you have it, AB you have, so it is a prime implicant, it is over there. A C dash D is also there, option B is there in the minimized Boolean expression. It is a valid prime implicant. Next it is B C dash D C, whereas we have only B C dash. So this should be the product term which is not a prime implicant. This is a essential prime implicant, but the option is something else, B C dash D. So C is your correct option. That is, it is not a essential prime implicant. A dash C dash D is there in your solution. It is a essential prime implicant. So B C dash D is not a prime implicant, and also it is not the essential prime implicant. Okay, thank you.